Greetings, everyone. Today we're going to explore graphing systems, specifically those of inequalities. And today, make sure you're in the right area of our notes. We're starting off where y is solved. Alrighty, first let's do a little bit of review of inequalities, specifically graphing inequalities. Remembering that less than points left, and generically, that is when we shade below our line. If it's greater than, that would be above our line. Less than would be below. And greater than would be above. Now, why do we have this 4 times? Because that line underneath, if it is just less than or just greater than, we draw a dashed line. Dashed, dotted, broken, however you want to think of that type of line. If it has a bar, meaning if it is or equal to, then we need a solid line. Now, this is all review, and so if you're struggling with more of the understanding of this, please see our graphing inequalities video. All right, let's jump straight into the examples. The first line, and I'm going to color code to follow along. My beginning is positive 2. So we begin on the y-axis. That's our y-intercept. My move, my slope is 3, but remember, rise over run. Rise 3, run 1. If there is no run, it's 1. All of this is review. And so if you're struggling, you need to see previous videos for those foundational pieces. Now, before I connect my dots, is this one solid or dashed? This would be dashed. And so make sure you draw it in a way that looks dashed, or go off the graph with some dashes to make it more obvious. And then we're going to shade right away. And so if I read this, this is less than. If I go to my beginning dot and I shade less than that dot, if I shade the y values less than, those are below. And so I'm going to use sort of a highlighter here. Yours is going to turn out much nicer than mine is, but we're shading below the dots. So technically all of this is below the line. All right, and we've done assignments of this before. So what are we changing today? Today, we are going to graph a second inequality. And so we're going to begin at -4. 1, 2, 3, 4. Our m, or our value in front of x, our move is +1, +1, +1. Now, in the past, when we've graphed systems, we cared about where they crossed, but this is not a system of equations, this is a system of inequalities. So now I have to switch gears. I do not care about where they cross exactly. We also have a dashed line again. It's kind of hard to see, right? And so that's why I tried to go off the graph with some dashes. Now, if I look at where it's shaded, this green line, I need to shade greater. So if I go to my beginning and I say shade greater, that would be above the entire green line. That's all of this. And so what we most care about, what matters, is where our shading intersects. And so with your pencil, you're going to go and see, where did my shading overlap? In this area between the two lines. And in that area, you want to make that extra clearly double shaded. And so a strategy can be, and maybe you've realized this just now, when you do your initial shading for each one individually, shade very lightly. Let's take a look at the next one. Our first line begins at -1. Our move, our change, our rise 1, run 2, rise 1, run 2. Our type of line before we connect, it should be solid because of that bar under it, and yours will hopefully be drawn better than mine. Oh, hey, that wasn't too bad. And now let's talk about shading. We want to shade this line greater, greater. That means above. And so very lightly, I can't do lightly on mine, but you can. Very lightly shade above your line. All right, let's take a look at the next line. This one's special. One letter, one number. Let's go to the y-axis at 4. 1, 2, 3, 4. And my Mortvet trick is slash the y-axis at 4. But before I slash too crazy, I need to make sure it's dashed. Kind of hard to see on mine, so I'm going to go off the graph a little bit just to show those dashes. Now our shading. Our shading is less than the green line is the bottom half of the graph. And so you want to shade all of it lightly. And here's what we're going to do. We're going to go back and say, okay, where is it double shaded? Double shading says that all of the points in the double shaded area would work and be true in both inequalities. Meaning I could pick this dot, it would work in both inequalities. I could pick this dot, it would work in both. I could pick this dot. Any dot in the double shaded area works. All right, let's keep going. We're going to begin at 5. 1, 2, 3, 4, 5. We're going to move negatively 2 over 3. So rise -2, run 3, -2, 3, -2, 3. I'm going to go the other direction because I want to try to fill this graph. It's a solid line since it's or equals to. And let's shade. If I follow my shading rules, it says less than. Less than means below my dots. And so if I shade below my dots, it's all of this. All right, let's take a look at the next one. We're beginning at 5 again. And in the past, that dot mattered, right? But now the shading matters, right? Whatever you do last matters the most. And so we're going to count our rise, run, rise 2, run 3, rise 2, run 3. Kind of creating this perfect X right there, aren't we? Very symmetrical. It's a solid line, so we're going to have a solid line. And let's talk about shading, most important. Less than. That means I want to shade below every dot. So if I shade below the line, I'm down here. Now we want to go back and exemplify where the double shaded area is. And so it's sort of this bottom V here, right? And so you want to fill and make sure that graph looks truly double shaded. This one should go pretty quick, it looks like. Less information. This one's special. Let's go slice the x-axis at 3. The x-axis at 3 would be a vertical line, and it's going to be dashed. Dashed, dashed, dashed. Now, this is special, right? There is no above or below. I can't shade above or below, and so special vertical line gets special attention. Less than means left. We're shading the x values that are less than 3, right? All of these are less than 3. Okay, let's look at the next one. Technically, there's a 1 in front of that x, and so this is slanted. It doesn't have a beginning. So what is my beginning? 0. I can add 0 without changing the equation. So we're beginning at 0. My move is +1. +1, 1, 1, 1, 1. Perfect diagonal. And because it's got an or equals to symbol, it is a solid line. Shading. This reads as greater than. Greater than means above all my dots. If I shade above all of my dots, I am shading above my line. Now you'll see it better with your pencil shading, but let's go back and clarify where is the double shading. It's left of my vertical line and north of my slanted line. And so my double shaded area exists here. All right, example 5. Let's begin at 2. Rise 3, run 1. It is a dashed line because it's not or equals to, it is just less than. And because it's less than, we need to shade less than. If I shade less than each dot, below each dot, I am shading here. All right, my next one, we're going to begin at -4. Oops, 1, 2, 3, 4, almost miscounted there. We are going to move -3. Oh, those signs make all the difference. That means rise -3, run 1. And I like to fill the graph just a little bit more. I think it makes the shading easier if we have more information. We're going to have a solid line from one end to the other. Arrows still matter. And this time we are going to shade less than my line. So less than every dot, right? If I go less than every dot, it's like this, right? So we're going to fill in less than that green line. So let's talk about and clarify and reshade our double shaded area. Our double shaded area is within this little triangle. And technically it keeps going south forever, right? Because of those arrows. So any of those dots in that shaded area work in our inequalities. All right, this one looks super fast, doesn't it? We've got a special line here. Let's go slice the x-axis at 1. That's a vertical solid line because it's or equals to. And if we shade less than the x value, that's left. It's the one time we go left or right. Okay, let's take a look at the next one. It is also special. Let's go to the y-axis at -5. 1, 2, 3, 4, 5. Let's slice the y-axis, but this time we have to slice it with a dashed line. So maybe go off the graph to see those dashes easier. And for shading, we want to shade greater than. That means above my dots. Above my dots is all of this top half. I can't really call it a half, but you know what I mean. And then we care about the double shaded area. Look at what we just created. We created our rectangle of double shaded area. So with your pencil, right, make that area darker. I have to see all shading, and I have to see where the double shaded is. Alrighty, let's keep going. We've got a couple more here. Let's begin at -1. Let's rise 1, run 2. And we're going to draw a dashed line. Try to make it obviously dashed. Our shading says greater than. We're going to shade greater than every dot. So that means above the line. If I shade above the line. Let's take a look at the next one. Well, I could think of this as point slope form, or let's do a really quick distribution. If I do a quick distribution, it's all nice numbers, and then it looks like a typical SIF inequality. So let's begin at -6. Let's rise, run 2, rise 2, run 1, rise 2, run 1, rise 2, run 1. And notice they don't cross at an exact dot, but that doesn't matter. It doesn't matter because we care about the shading for inequalities. So what matters is that I see dashes and the shading. The symbol says greater than. Greater than means above each dot. So let's go shade above the entire green line. And we're going to go back and exemplify the double shaded area. So I'm going to trace that double shaded area first. And then with your pencil, you're going to go darken that double shaded area up. Alrighty, example 8, let's begin at 1. We're going to rise 3, run 1, rise 3, run 1, rise 3, run 1, because that's our move, our slope. We want a solid line because it's got a bar, because it's or equals to. And we want to shade less than. Less than every dot is below every dot, which means I want to shade over here. Let's look at the next one. The next one has parentheses. And so let's just take a moment to distribute. And the fact that it's a half doesn't change anything because taking a half of 2 is 1. And taking a half of 2 is 1, right? When we distribute, we multiply. And so we're going to begin at 1. Begin at 1. Oh, I chose to use red here. I really wanted to use green. Can I fix that quick? I'm going to stick to the same colors I've been doing here. All right, let's go green. Green, begin at 1. Move positive 1, positive 1, positive 1. So see if your shading's light, as it should be, that'll look better than it does on mine because I can't shade lightly. All right, we want to connect with a dashed line. Kind of hard to see, so maybe stretch those dashes out. And for shading, less than. We want to shade less than every dot. So if I shade less than every dot, I'm shading less than my green line, which means we're going to go and show off our double shaded area. I like to kind of trace out where I'm going to be first and then go darken it up. Alrighty, let's begin at -1. We're going to move 1, 5. That's very slow sloping. Rise 1, run 5. Rise 1, run 5. That is almost, or a very slow sloping line, closer to horizontal, right? And we want dashes. We can clearly see dashes on this one. No questions there. And for shading, it says greater than. Oh, these are so much easier to shade when they're slow sloping like that. The shading above is much more obvious. All right, let's look at the next one. We're going to begin at +1. This time my move is negative. Down 1, right 5. Down 1, right 5. Again, dashed. Easy to show dashes when they're far apart like that. And our shading says less than. Less than. If I shade less than every dot, I'm shading sort of the bottom half almost, which means my double shaded area is this skinny little triangle. It meets at a dot. It doesn't have to meet at an exact point, but we're shading this triangle off to the left. Alrighty, Lots of examples, options. Again, all of these had y already isolated, and so it did go pretty quick. So make sure we've got our beginnings, our moves. We need to think solid or dashed. We need to think shading. And then most important, what's new today is the double shaded area. Most important, that is called your solution region. Alrighty, make sure to check out Google Classroom, see what tasks we have, what's going on in class, and until next time, have a good one.